Population parameter versus sample statistics. Population parameter is a number that describes a whole population. I have a population, a big picture. There is a number describing a characteristic of this population. That is called a parameter. And then a statistic, I have a big picture. I took a subset from this picture. That is my sample. And then I have a number describe a characteristic of this sample. That number is called a sample statistic. For example, population or students at our college. And then a parameter, the true average GPA of all students. So we have all students, let's say 10,000 students. Everyone has a GPA, and then a true average GPA of all students. That means you need to get those 10,000 GPA, you add them up, find a sum, and then divide it by 10,000 to find the average GPA. So this is very hard to get, but if you can get it, then this number describes a characteristic of the population. Okay, assuming there are no technology, no database, so let's take a sample. Okay, let me move this away. The sample is you randomly survey 100 students, collect 100 GPA, and then the statistics is you find the average of these 100 GPA. So you add them up and then you divide it by 100 students. So this is easier to do. And then whatever average GPA you have, and this is the average of your sample compared to the average of the entire population. The average of the entire population is called a parameter. The average of the sample is called statistic. Some exercise. You can pause this video, do it first, and then I'll resume to the video to see how I do it. After measuring every bridge in state, Caltrans should be represent California Transportation Agency, something like that. I don't know the actual name of that, is my best guess. Caltrans reports that the average age of a bridge in California is 4 years. So this one is a population because the average is based on all the bridges in California, all of them, every single one of them. So that is whatever average you found, that is a parameter or population parameter because that is a characteristic of the population. And then number 2, somehow I type 22. A financial analyst calculates that the 50 tech companies in her study had an average of margin of 18% last quarter. I am sure that there are definitely more than 80 tech companies. So this, did I say 80? 50 tech companies. I am sure that this is only a sample. So this is only a sample. And then the 18% describes a characteristic of the sample. Then this 18% is a sample statistic. And then number 3, after an election, it is determined that 60% of all the registered voters in Santa Clara County actually voted. Okay, this 68% is based on all the voters. So all the voters in that county is a population. The 68% describes the population, then the 68%, this 68% is a parameter. And then number 4, researchers weighed 50 sea lions on Pier 39 and found that the average weight was 650 pounds. That must be a sample. This must be a sample because let's say a sea lion went to the water, then you cannot measure the weight, right? You are not going to jump into the water to catch the sea lion. So this is a sample. And then this one has to be a statistic. The 650 pounds, that describes a sample, that must be a sample statistics. And then last one, an audit of every single transaction at a coffee shop showed that 22% of all sales were paid for with cash. Every single transaction, that is what they mentioned, right? They mentioned every single transaction, every single, that is a population. And then the 22% describe a population, then this 22% is a parameter. Okay, so let's see. The first one is a parameter, right? and then a statistics, and then a parameter, statistics, and then a parameter. All right, so that is the end of this video.